All right, what should be a quick video right here. We're looking back at our histograms. We're not actually making any histograms here, but that being said, a prerequisite skill will be making sure that you can understand how histograms are used, understanding how to read a histogram, which really came into play when we were creating histograms earlier in the first cycle. This video is suitable if you're in grade 11, if you're in a 3C class in particular. We already know how to create a histogram from a list of values. When we're building our histograms, there are really common general shapes that show up from our patterns. When I say those shapes, I say they're in general because we're unlikely to have these perfect shapes. But the idea is if we have a shape that's starting to look like this, that really if I follow the tips of each of our bars, a general shape like this, we call a normal distribution. Now, a normal distribution comes into play often when we're working with randomness. So if we're working with, say, the heights of a certain group of people, let's say we're working with the weights of a certain group of people, let's say we're working with grades of a group of people, or let's say we're working with, to call back from a previous lesson, we're working with the probabilities of rolling certain sums of 2 dice. Now, what are the characteristics of a normal distribution? Well, we're going to expect the mean, median, and mode to all be right about smack in the middle. We're going to expect it to be far more popular to have middling values and far more rare to have extreme values, extreme highs or extreme lows. Now, those are true for each of these different scenarios that we're looking at right here. Now, next, we could end up with, instead of having a normal distribution, sometimes we end up with something called a bimodal distribution, which really has 2 peaks. Bimodal, modal, well, we know what modes are, so this might have 2 modes, but really the idea is here that most of our data is within 2 separated groups. Now, we're going to end up with this kind of a shape if we're taking a histogram, let's say, of the weight of vehicles, if we're taking 2 different types of vehicles, let's say motorcycles and trucks. We will have a lot of our motorcycles all down here. We'll have a lot of our trucks that weigh much more than motorcycles weigh up here, and rarely will we end up with many vehicles in the middle. We'll have 2 distinct groups. That's what would tell us that we're working with a bimodal distribution. We might also end up with a bimodal distribution, let's say if we're working with the height of students within a classroom that is currently having reading buddies. Let's say a class of grade 2 students combined with a class of grade 6 students. Well, we're expecting the grade 2 students to be shorter. We're expecting the grade 6 students to be taller, and we're not expecting a lot of students to be directly in the middle right here. Now, let's say if we had reading buddies between, say, grade 4s and 5s, then we'd probably be expecting more of a normal distribution because of how much overlap would come into play between grades 4s and 5s, but I imagine grade 6s, grade 2s, most of their heights will be considerably different. We would expect a bimodal distribution in this case. We would expect that bimodal distribution to come into play whenever we have a group that's really made up of 2 different subgroups that would have different characteristics for what we're looking at. Okay, so in this case, let's say we were looking at those reading buddies. The key is they would have different heights. That's what would give us a bimodal distribution. But if we were looking at a different characteristic, I don't know, let's say how many hats they owned, well, if we're looking at the number of hats that students in grade 2 own and students in grade 6 own, I'm not sure there would be much of a difference, whether you're in grade 2 or grade 6. You might expect a normal distribution in that case. But a bimodal distribution has 2 different peaks, bi meaning 2, modal, modes that we've already looked at and studied with. I know, Sadie, I'm sorry, I'll be with you in just a moment. Now, lastly, the last common pattern we're going to look at are skewed distributions. Now here we look at a shape that looks something like this. We would say this has a left skew, where the skew is elongated tail of our distribution, or we could also have, let's create another fake histogram right here. We could also have a right skew distribution that has its skew, that has its tail on the right hand side. Now, the idea here, we would expect this kind of a pattern to show up if we're working with something that has a maximum either accepted or a maximum standard value that we're working with. Let's say if we were taking if we were collecting data of all of the lengths of pencils within a school. Well, we would expect the lengths of pencils in a school to end up with maybe a left skew, because most pencils will have a pretty standard maximum length. From there, we would have fewer and fewer pencils that make it to these shorter and shorter lengths, right? So we could expect all of the, in particular, this standard pencils, we could expect to end up with this kind of a distribution. Well, let's say instead we're working with a grass length. Well, if we have just planted grass seed and we take some data on the lengths of the different grass stems, then we might expect, because we've just planted it, we have many that are very short, but none obviously have a negative height. We cannot have a negative height for anything. That doesn't make any sense. So we would expect none to have a negative. So our accepted minimal value here would be 0, a height of 0. And from there, we would expect fewer and fewer pieces of grass, perhaps, if it's more recently been planted, to be taller and taller. The opposite might be true. If we're working with grass that has just been mowed, we would have a maximum value, and maybe far rarer would we have grass that's younger, that has not yet reached that maximum height. So a skewed distribution comes into play when we have ourselves an accepted minimum or maximum value. A bimodal distribution comes into play when we're working with two different groups within our data set. And a normal distribution comes into play when we're working with randomness. Are these the only situations? Are these the only patterns? No, but these often show up. All right, so I'm hoping you're feeling a little bit more comfortable with our types of distribution. Nice work.